In this lesson, in 7.2, we're going to be simplifying expressions. And the three new terms that we're going to be discussing in this lesson are like terms, coefficient, and constant terms. You'll notice on the example that is in blue and red that there are examples of each of these. Our coefficients are in red. There are a number that goes with a variable. So notice, in our first coefficient, the coefficient is 1 because there is an understood 1 in front of the x. Our next coefficient is -2. The 4 and the -10 are both called constant terms. We're going to go into greater detail about coefficients and constant terms, and then how to determine which are considered like terms. In our first example, is terms. Terms are part of an expression. In our first example, we need to denote how many terms there are in this expression. You'll notice there is 1, 2, 3, 4. So in this expression, there are 4 total terms. Number 2, terms that have identical variable parts are like terms. I'm going to also get you to underline identical variable parts. For example, 2x plus 3 plus 6x plus 8. Our like terms in this expression will be 2x and 6x are like terms, and the 3 and the 8. Note that each of those like terms have in common, on the first example, they both have an x for a variable, and then the like terms, 3 and 8, are both constant, and we're going to go into explaining each of those on the next slide. So we're going to identify the like terms in each of these. In A, we have -3 plus y plus 8. Our like terms are going to be the -3 and the 8. Both of those are considered constant. They are both considered constant terms because they will not change at all. In our example B, we need to determine what the like terms are in B. Our like terms are going to be 2a and a. Note that I did not put a b in the like terms because it does not contain the same variable. So 2a and a are like terms in that expression. So our first set of like terms in C is going to be 1/2 y and 6y. So our other set of like terms in C will be -3 and -9. So you'll note in D, our like terms are y and -y, x and 2x. Please remember that the sign in front of the number or the variable states if it is a negative or positive. So if you're not sure if it's a negative, look in front of the variable or in front of the integer. In our next term, we're going to talk about coefficients. Coefficient, a number which multiplies a variable, is called a coefficient. So in example 1, we have -3y. The coefficient is -3. In example 2, we have -1/2 y plus 4x. Our coefficients would be 1/2 and 4. So, in example 3, please note that there is an x there. There's an understood 1 there. Even though it's invisible, there's still an understood 1 in front of that. So the coefficient for that phrase would be 1. So our coefficients in 4 will be 3 and negative 2. Now, our last and final term will be a constant term. A constant term is a term that has a fixed value and does not contain a variable. In example 1, the constant term in that example will be so the constant term in example 2 will be negative 1. So in example 3, there is not a constant term in example 3. In example 4, the constant term will be negative 8. And now we have an exercise where we're going to identify the coefficients, the constant terms, and the like terms in the expressions. I'm going to pause this. We're going to work on it in class, then come back and show the answers all at once. Okay, please note the coefficients on 6a will be 5 and 3. The constant term or terms would be 2. And the like terms will be 5x and 3x. Okay, please note in B that our coefficients are 1 and negative 2. Constant term is 4. Our like terms will be x and negative 2x. So in 3, our coefficients are negative 3 and negative 1. The constant terms are 1 and 2. The like terms are negative 3y and y. And then the other set of like terms would be 1 and 2. I need to go back and correct myself on C. The like terms are negative 3y and negative y, and then 1 and 2. On D, the coefficients are negative 10 and negative 5. Constant terms are 5 and 3. The like terms will be negative 10y, negative 5y, and the other set would be 5 and 3. There. Okay, so my coefficient or coefficients for E would be 2. Constant term is negative 8, and they do not have, that expression does not have any like terms. Now, you will be asked to simplify expressions. Simplifying expressions is when you cannot actually solve them because you do not know what the variable is. So you'll be asked to simplify them when you have variables and there are no equal signs. So what we do in order to simplify an expression is we're going to combine the like terms. Now when you're given an expression and they ask you to simplify it, you'll combine the like terms. But before you do that, you are going to simplify the expression. If it is subtraction, you do what, class? So, in our expression right here, 7c plus 9 minus 3c, we are going to write the expression as a sum. 7c plus 9 plus negative 3c. And with the community property of addition, I can move the terms around. I changed it to addition. Since I changed it to addition, I can commute or move the terms around. So now I can combine 7c plus negative 3c. If I have 7 c's and I take 3 c's away, I have 4 c's left. Then all I have left is my constant term of a 9. So we have examples here of simplifying these expressions. So they're telling you to like terms may be combined to simplify the equation. These are not equations. These are going to be simply expressions because they don't have equal signs in them. So I'm going to pause the video. We'll do 2 at a time and come back and check them. In A, when you're simplifying terms, you will put the constant term first, and then the variables will follow in alphabetical order. So the correct way to start on A would be to put your constant terms, and we just had a 2 there. So 2 plus, and then we combined our like terms of 5x plus 3x, and we got 8x. In B, the first thing we did was, in order to use the commutative property of addition, we had to add the opposite. So we changed x minus 2x plus 4 to x plus negative 2x plus 4. I put the constant first. We combine the constants if there were any need to combine. Then I had 1x plus negative 2x, and that equals negative 1x. And you simplify that to be 4 minus x. So notice in C, we combined our constant terms, 24 plus 4b. In D, 4 minus 5 is negative 1, so negative 1 plus negative 8c, which is also equal to negative 1 minus 8c. So in E, I noticed there were not any constants, so I just combine my like variables. 3b minus 8b is negative 5b plus 7b is equal to 2b. In F, negative 8 is my only constant. Then I had 2d plus 3d is 5d. Okay, so in G, my constant terms were 14 plus 3, so those equal 17. Then I combine my coefficients. 2y minus 6y is negative 4y, and simplified that. In H, combine my coefficients of 4 minus 8, which is negative 4. Then my coefficients, 9x minus x, gives me a positive 8x, so I simplify that to negative 4 plus 8x. So in A, I did a lot of writing in that for you to understand, but notice our constant terms cancel each other out. I have negative 2 plus 1 plus 1, that equals 0. So we have A minus 2A left, and just for teaching purposes, that's understood to be 1A minus 2A. Then I add the opposite, and I had left was negative A. In J, my constant terms, 5 minus 4 is 1. I have 3 y's, and then all I have left in my variable z is negative z. Okay, and K, we're going to use the distributive property to where we distributed 5 to everything inside the parentheses. So 5 times z is 5z, 5 times positive 2 is 10. And then we brought down our 8 that we had left. So we have 5z plus 10 plus 8. We combined our like terms. 18 plus 5z is your final answer for K. Then L, again, we use the distributive property. So I went ahead and wrote 4b minus 2 plus 2 times b is 2b. Distributed the 2 to everything inside the parentheses. 2 times 1 is 2. So now I got to simplify 4b minus 2 plus 2b plus 2. Our constant terms cancel each other out. So we have 4b plus 2b, and that's going to equal 6b.
I'm trying to get it.
Now, on M, again, we use a distributive property. 5 multiplied everything times what's inside the parentheses. So we end up with 5w minus 20 plus w plus 8. And we combined our constant terms. Negative 20 plus 8 is negative 12. 6w plus w, 5w plus w is 6w. On M, that was the answer for M. On N, before we even had to use a distributive property, we noticed that the 2t and the negative 2t cancel each other out. So all we need to do is distribute 2 times 5, which is 10, plus 8t. Okay, we have one last word problem. I'm going to pause the video, let you read it, and let's work through it. So we took the information given to us. A rectangle exercise mat is twice as long as it is wide. So we put W for the width, twice as long as 2W, and we needed to find the perimeter. So 2 times the length, 2 times 2W, plus 2 times the width, because there are 2 widths. We simplified it to 4W plus 2W is 6W. So we're going to be solving and writing an expression for the perimeter of the rectangle. We have 2 lengths, which is z plus 3, plus 2 of the widths, which is z minus 1, I'm going to use a distributive property, 2z plus 6 plus 2z minus 2, because that is a negative. 2 times negative 1 is negative 2. Going to combine my like terms. 4z. 6 minus 2 is 4. Or 4 plus 4z. Again, we cannot solve them, but we can simplify them.